Hello everyone, welcome to our channel Mathematics Parshala. This is a problem of CSIR NET December 2023 Mathematical Sciences. This is a question from functional analysis. The question ID is 704099. This is a question of part C. First we read this question. Define S equal to this set y belongs to C1 0 pi. That means the set of all real valued continuously differentiable functions on closed interval 0 pi. So all those functions y such that y dash x, the first derivative of y, is continuous on 0 pi. Satisfying this y at 0 equal to y at pi equal to 0. Norm f is defined sup norm or infinity norm by max x belongs to 0 pi mod fx for all f belongs to s. Then define here, actually this is a printing mistake probably, that this should be b0 0 epsilon. That means the open ball centered at 0 and radius epsilon. So all such f belongs to S such that norm f less than epsilon. So this b0 f epsilon should be replaced by b0 0 epsilon, and also this b1 f epsilon, probably this is also a printing mistake. This should be b1 0 epsilon. That means the set of all f belongs to S such that this norm f plus norm f dash less than epsilon. So then consider the functional j such that s to r given by this jy equal to this. So now this is the option that then there exists epsilon greater than 0 such that this 1, 2, 3, 4. So now one by one we now discuss the options. See, first, if we have to prove this option 1, then we have to find some epsilon greater than 0 such that for all y belongs to b0 0 epsilon, this jy less than equal to j0. And if we counter this example 1, then we have to show that for any epsilon greater than 0, there exists at least y belongs to b0 0 epsilon such that this jy is greater than j0. Then the option 1 will not be true. So see, actually here first we show that this option 1 and option 2 are not true. So to show that, we have taken arbitrary epsilon greater than 0 and we find some yx, some y belongs to b0 0 epsilon such that this option, this condition jy less than equal to j0 is not satisfied. So we take here epsilon x by pi square pi minus x. So we have taken arbitrary epsilon. So this epsilon may be less than 1 or greater than equal to 1. So if this epsilon less than 1, then we take this, and if this epsilon greater than equal to 1, then we take simply 1 by pi square x pi minus x. So now see this, just we verify for this epsilon less than 1, the other case will be exactly in similar manner. So see first, then clearly this norm y, infinity norm, will be equal to, just simply this will be epsilon by 4. Just simply verify, just take y dash x equal to 0. So find all such y such that y dash a y attains maximum minimum, and for those simply just we can find that at x equal to pi by 2 y attains its maximum, and putting x equal to pi by 2 at y we have epsilon by pi. And also simply and similarly verify y dash norm y dash infinity norm. This will be also epsilon by pi. Then here this as this less than epsilon, so here y belongs to b 0 0 epsilon. And also here norm in norm y plus norm y dash equal to epsilon by pi plus epsilon by pi. This is equal to 2 epsilon by pi. This is also less than epsilon as 2 by pi less than 1. So y also belongs to be 1 0 epsilon. So we have taken arbitrary epsilon greater than 0 and we find one y such that y belongs to b 0 0 epsilon and also b1 0 epsilon. Now see here, for this y, this jy is equal to integration 0 to pi 1 minus y dash square into y square dx. Clearly here this norm y dash is less than epsilon, and if epsilon is greater than equal to 1, then we take this. So similarly we can find this actually less than 1. So this will be less than 1. So as this is sup norm, so norm y dash less than 1 implies that this y dash x less than equal to 1, less than 1 we can write, or less than equal to 1, whatever, for all x belongs to closed interval 0 pi. So we have this y dash square also less than equal to 1 for all x belongs to here. So we have this 1 minus y dash square greater than equal to 0. So we have this 1 minus y dash square into this y square is also greater than equal to 0. So this is greater than equal to 0 for all x belongs to 0 pi, and hence integration this, that is jy greater than equal to 0, and this is actually j0 because j0 is simply 1 minus y dash square into 0 square dx. So this is simply 0. This is actually this will be actually strictly greater than, sorry, this will be actually, otherwise this jy this y will be identically 0, which is not so. So this jy is strictly greater than 0. So we have this jy greater than j0. So option 1 is not true, as we find one y belongs to b0 0 epsilon such that this condition is not satisfied. We have jy greater than j0. And also for option 2 we have same y belongs to b1 0 epsilon such that jy greater than j0. So option 1 and option 2 is not the correct option. Now look at option 3. This similar manner we can show that option 3 is also not the correct option. So for this, similarly we have taken arbitrary epsilon. We have taken arbitrary epsilon and we take yx equal to simply epsilon into pi minus x into 1 plus x to the power n. We have to take one x also multiplication, epsilon x pi minus x into 1 plus x to the power n. If this epsilon less than 1, and we take simply in the place of epsilon just 1, so x into pi minus x 1 plus x to the power n if our epsilon is greater than or equal to 1. So for simply we consider this part epsilon less than 1, and exactly in similar manner this epsilon greater than 1 will be we can show for this case. So now check here that y clearly this y belongs to C1 0 pi, and in for option 1 and 2 we have taken that y. This y also belongs to C1 0 pi. Just forget to just mention that this y also belongs to C1 0 pi clearly. Okay. So now here this y belongs to C1 0 pi clearly, and see here this y dash x equal to write this yx as this pi minus x into x plus x to the power n plus 1. Then y dash x is minus 1 into x plus x to the power n plus 1 plus 1 plus n plus 1 x to the power n into pi minus x. Now now simply check here that this is very clear that this y belongs to b00 epsilon. Exactly in similar manner we just simply verify that this norm y will be less than epsilon, and see here if we take at x equal to 1, then what is our y dash x? That is our y dash 1. See, this is actually here 1 plus 1 plus 1 plus n plus 1 into this pi minus 1. So that is actually minus 2 plus 1 plus n plus 1 into pi minus 1. So this is minus 2 plus pi minus 1 plus pi minus 1 into n plus 1. So look at this n plus 1 case. We have not mentioned what is our n, and we take here n sufficiently large. Sufficiently large we can take as n tends to infinity. So this, as we have taken this n tends to infinity, then this y dash 1 also tends to infinity, so this will be very large. So our y dash 1 square will be very large, and hence this 1 minus y dash square will be very small and negative case. So this must be integration 0 to pi dx must be less than 0. That is our j0. So we have such y belongs to b00 epsilon such that this jy is less than j0. So option 3, look at option 3. So For any epsilon, we have such y belongs to b0 0 epsilon such that this jy greater than equal to j0 is not satisfied, jy less than j0. So option 3 is not the correct option. Now look at option 4. Look at option 4. See, this option 4 will be only correct option, and this is very easy to show because to prove option 4 we have to find one epsilon. So simply we take epsilon equal to 1. So now we show that for all y belongs to b1 0 epsilon, this jy greater than equal to j0. So take one arbitrary y belongs to b1 0 epsilon. So as y belongs to b1 0 epsilon, we have this norm y plus norm y dash is less than epsilon, that is 1. So we must have norm y dash is less than equal to norm y plus norm y dash, that is less than 1. So as this sup norm is less than 1, we have this y dash x less than 1 for all x belongs to 0 pi, as its norm is less than 1, that is sup norm. So we must have y dash square is also less than 1. So we must have this 1 minus y dash square is greater than equal to 0, and also into y square, that is greater than equal to 0. So this integrand is this is strictly greater than 0. So this integrand is as y is not taken as identically 0. So this integrand is greater than 0. So we must have this integration 0 to pi 1 minus y dash square into y square. This is strictly greater than 0, and this is our jy, and this is 0 equal to our, this is j0. So we have this jy greater than equal to j0 is satisfied for all y belongs to b1 0 epsilon when we take epsilon equal to 1. So option 4 is the correct option. So here option 1, 2, 3 are not the correct options, and option 4 is the only correct option. This is the solution of this problem. Thanks for watching.